begin with the panel. This question is for you, Mr. Sumedh. The question is, if I speak of predictive maintenance and AI-powered smart inspections, they say it is increasingly critical in managing distributed assets like rooftop solar, EV charging, whichever is happening right now. So from your perspective, what models or frameworks can utilities adopt to ensure these inspections move from pilots to mainstream practice?
So, thanks, Sohail, for asking this question. I think this clear-cut answer is where the pilot is actually providing you a high ROI and helping you to ensure some KPI which utility is trying to address. Maybe a power reliability, power quality, that is met. So, for example, uh, I just took an example of drones. Okay, now drone actually has helped a lot in different cases. For example, if you recently have seen in Jaipur, what they have done is because of inspections, they were able to increase the number of new connections. So I'm just trying to help you understand that it's not that, okay, this is one thing that you are only catching the theft. It is actually helping you to increase the new connections because people now understand that without going for a new connection, they may not be having a transformer itself. Uh, at one place, they found that the transformer was overloaded because the theft was happening, and the utility decided to remove the transformer itself. That okay, consumers naturally will gravitate to go for connections, and then only I will have this transformer. So it all depends on the ROI and the KPI on which you are working on. For utility, it is always 24/7 reliable, quality power. So that is a small and simple way to see and understand what utility is eyeing for. And out of these two, quality and reliability, one thing is met, you should go for that.
Adding on this only are the challenges in this space.
So what challenges I was mentioning was two, threefold. One was about the workforce. I mean, at utilities, generally, we do not have cadre of people who understand this kind of technologies really well. Like Arkesh was also mentioning now that it's an artificial intelligence. It has to be mapped with the human understanding and the use case. So that kind of a cadre has to be created, and that is right now, that is a challenge that is missing right now with utilities. Second is high impact demonstrations. There are multiple pilots going on, but identifying which pilot is going to provide significant ROI is something which utilities should eye for. Utilities should take it forward, provide that ecosystem to the technology providers. That is really helpful. Third is about the governance and partnerships, because without these, any utility cannot progress. So if you find a good partner, at least ensure that he stays in that ecosystem by providing him sufficient time, sufficient trust, so that at least he can build that ecosystem and scale it at the utility level, and it should not get limited to a pilot level. And I think one thing, anyways, Arkesh mentioned was about the SCADA, which I was trying to also allude to. They are legacy systems. So how those legacy systems need to start talking to the new systems, what kind of patches should be there, is something to be looked.
Just add one point here to the 3 points that sir mentioned. Also, the data, the availability and documentation of data is a big problem right now in the utility sector. Simple example. So I was talking about transformers. One of the challenges that happens is ideally your transformers need to be mapped to certain feeders and feeders to customers. Now, randomly these mappings are changed by the operators, and there is no data that is available to show exactly what mapping is there. So you do not know the load profile that a transformer has gone through in its life. Now it's almost impossible to make any AI model to actually train that transformer. So there are these challenges also that exist on the ground.
Okay, the same thing, in continuation with these challenges. If I speak, so what's the next big leap, if we can say, big leap in the AI can unlock resilience and reliability in power sector? What do you say about this?
Data which is coming from smart meter is going to give a big leap. That is what I can all say that the humongous amount of terabytes of data which is going to come, how you are going to analyze it, what kind of insights it is going to generate, what kind of new programs you can design basis that data is where I think the fortune lies, and that is what everyone should harness. Like Behraji was mentioning about forecasting, naturally that is the most important thing people are eyeing for because it helps us to reduce the deviation settlement and all. Then customer disaggregation, understanding which appliance is contributing, whether we should go for a 3-star or 5-star rating appliance. That is where you can focus on. Then it also comes about behavior. I mean, what kind of behavior you can see, because what we are also seeing, Soil, is peak is becoming peakier day by day. And if you are able to reduce the peak, and that too, it happens in the non-solar hours. So anyways, you are using coal to meet that. So if you are able to shift that peak to solar hours or reduce it, it reduces the it decarbonizes the grid. That is the final aim, that we try to decarbonize the grid. We ensure that we are more sustainable and the load curve becomes more stable or more straight. That definitely adds value.
Yes, we would like to hear from you, Arkesh, on this.
So I agree. Actually, this peak shifting is, I think, one of the biggest initiatives. The second thing is actually introducing batteries into the grid at various places. That is also extremely important. So batteries can be placed in the grid at 6 locations: at the generation site, at the transmission site, at the distribution level, at the individual industries, uh, at the at the auxiliary service providers, and also to do peak shaving and things like that. So these are uses of batteries in the grid. So very strong capable BESS systems with proper energy management systems on top of them uh, is extremely critical to actually manage the grid. And these energy management systems, as well as the battery management system of the BESS, will play a vital role. AI will play a vital role in making these more resilient to fluctuations.
Okay, Arkesh, it was a nice, insightful talk. Gray, know, gray hydrogen, and it is cheaper. Then why green hydrogen is being used? Uh, obviously just to for the sake of environment, if I can say or anybody can say. But is there any
hydrogen is cheaper, and I would not say that it is cheaper. It is practically half. Gray hydrogen today in India can be bought at a price of almost, I would say, 150 rupees, 160 rupees maximum, while the green hydrogen is going to cost you about 330 rupees, 340 rupees, 350 rupees. Now, this difference, in fact, is very huge when we look simply at the numbers, or I would say the profitability of any product. But eventually, in the long run, this saving of 150 rupees or 180 rupees that we are saving right now by using the gray hydrogen, in fact, is costing us perhaps 5 times to combat the impact of the carbon that we are sending into the atmosphere or sending into the onto the earth. So the objective of the governments right now is to, as we all know, that by 2070 we have to kind of decided that Earth should be net zero, that there should not be any emission, or in case if there is any emission, then we have to have the mitigation policies in place to mitigate those kind of the effects that we have started seeing today even. So yes, when it comes to the pure numbers, green hydrogen is not economical, I would say. And that is the reason that all the major countries, including India, they have launched these kind of the missions. India, specifically for that matter, National Green Hydrogen Mission, which is offering, I would say, which is a package of 19,000 crores, more than 2 billion. The government is going to spend from their own pocket in terms of incentivizing the electrolyzer manufacturing capacity built out in India. For example, our company, GS2 Solar, in fact, has been awarded 105 megawatt of the manufacturing capacity. Now, under that, we have, for this 105 megawatt of the capacity, we have almost a incentive of 157 crores. That means per megawatt of the electrolyzer that we will sell, we will get some incentive from the government so that we are motivated to sell. We reduce the prices of our electrolyzer and industry can benefit or the end user can benefit. Similarly, the green hydrogen per kg, in fact, has the production link incentive, which is 50 rupees per kg in the first year, 40 rupees per kg in the second year, and 30 rupees per kg in the third year. So 3 years, the consecutive incentives have been lined up for the industry so that eventually the end user cost is reduced and the industry is motivated to use green hydrogen in place of gray hydrogen. But yes, despite all these, I would say incentives and the PLI schemes, there still would be a difference, and this difference, what the industry and the experts and the government are hoping that the way, for example, Sohail, you must be remembering the way it was solar in 2010. The unit cost used to be almost 15, 16, 17 rupees, and everybody was saying that no, this is not realistic, this will not work, nobody will afford this kind of the electricity prices. But today, just within 15 years, I would say, down the line, today we have the solar prices as 3 rupees, 3.5 rupees, or landed costs, I would say maximum 4 rupees, which is much better than, rather, I would say, today's thermal power. So it is a similar trend that is going to happen with the hydrogen as well, with the rise in the electrolyzer manufacturing capacity, with the increased usage of the green hydrogen, the prices would fall down, the production costs would fall down, the eventually bringing it to closer to the gray hydrogen. The target by the government of India is to bring the cost to 180 rupees by 2030. So today, in case if we have the gray hydrogen as 160 rupees per kg, and if the green hydrogen would be 180 rupees per kg, that is something that the industry can afford, that the common man also can afford in the end usage or in the end products.
Which India's clean energy milestone, which we have to achieve 27? What innovative business models or partnerships are emerging in green hydrogen industry? What do you see?
So he'll see partnerships, in fact, I would say, are at two fronts. The one front is wherein the foreign technology players from the US, from the Europe, and other parts of the world, in fact, they are joining hand with the Indian manufacturers. For example, we have joined hand with a South Korean manufacturer, AHES, and it's a technology transfer wherein we are going to get the technology to manufacture the electrolyzers here in Madhya Pradesh. We are setting up a unit there for the production of the electrolyzers. Similarly, L&T has tied up with McPhy, Nel Hydro, which is a Switzerland-based company and almost 100-year-old company in the hydrolyzers manufacturing and the green hydrogen. They have tied up with Reliance. There are many other players who have tied up in terms of the technology, in terms of the capacity building for the green hydrogen economy. Now, once this is done, then the second kind of the partnership that we have is that Indian manufacturers who are going to produce green hydrogen or green ammonia, they are tying up with the end users, because eventually the produced quantity has to be either domestically consumed or that has to be exported. So while India itself is a huge domestic market, but still the Indian manufacturers, in fact, last week only, ECME, in fact, has tied up with IHI of Japan, wherein they are going to export 1 million metric tons of the green ammonia to Japanese, power industry. Similarly, we are also working out a couple of agreements wherein we are trying to approach to the European players, and we will be selling the green hydrogen as well as green ammonia that we will produce using the green hydrogen for the export purpose in South Korea. Similarly, Europe is a big market because Europe is quite concerned, and I would say they always have been a leader in terms of the climate change and the adoption of the new technologies. So the consumer there are willing to pay a little bit of the extra price as well by consuming the green hydrogen ecosystem value products. So overall, I would say there are two kind of the associations or the JVs happening. One is in making the build out, the production capacities, the manufacturing. And the second kind of the tie-up that we see is towards the export of the green ammonia, green hydrogen, and derivatives. You might have seen that right now. In fact, a lot of aviation companies have started using the SAF, sustainable air fuels, which is a blend of the conventional gray fuel with the green fuel. Similarly, IOCL has now come up with a kind of the technology wherein they are converting the cooking oil, the used cooking oil, into a sustainable aviation fuel. While that is not a purely a green technology, but my point here is that the world is shifting gears, and slowly and gradually the whole of the industry and the sector is moving towards a carbon-free world, which is the aim.
Thank you, sir. Mr. Arkesh, before I end up, quickly just statement from your side.
Okay, so I can't give a basic concluding statement as such, but one thing I would like to say is that this data pipelines, edge devices, that is innovation on the hardware and the core software is extraordinarily important if AI has to come into the grid. So everything, all the data needs to be properly taken and stored.
Okay, guys and panelists, whoever have joined, thank you.